I saw this and I thought that's an interesting conversation. WebAssembly and Kubernetes go better together. And I wrote up my own feelings as I know them right now. Without reading the article, I wanted to think about what could possibly be with Kubernetes and WASM that are amazing. So what does WASM solve that containers do not? Because I assume when you say Kubernetes and WASM go together, you're talking about replacing containers with WASM. Now, I've heard the more secure argument, and this is maybe if each process has its own WASM runtime, maybe per customer runtime. So, like a single customer would share a runtime. But then is that secure enough if you do any type of sharing or have a single WASM runtime? Does that actually provide you that security, that isolation that you need? I know that there's a bunch of articles on how to make that more secure, but none of that has come to fruition just yet. Startup time. This is something I've heard, but this is another thing. They'll talk about how fast WASM startup time is, but it's for an already running WASM runtime. If you have to do isolation on a per WASM runtime for your customers running untrusted code, I actually think it's much slower than a container would be. I also think that containers are, like I've never had a container, even a database container, that takes more than 5 seconds to start. Like it's not, I don't know if those are. So anyways, those are the two things that I could think of. Hopefully the article has some other things that I'm not thinking of. Like I said, I didn't read the article. I came up with my own things so we could cross-reference what the person writing the article said and what I'm thinking right off the top of my head. Well, I spent about half an hour writing this up with just thinking on it. Well, and I thought about it some last night while I was trying to go to sleep. To be honest, that's about how much time I spent on it. All right, so WASM cons, lack of language support. You have to write it in Rust, Golang, Dart, Python, Java, Kotlin, JavaScript, or C++. If you're wanting to do it in anything else, it doesn't work because your language actually has to support compiling for WASM. There's the requirement to transpile. Your code only runs in WASM once it's transpiled, like it's a intermediate language that's run in the runtime. It still sucks to debug. This is a solvable problem. I double wrote this. It lacks good debugging, build and testing tooling. So again, a solvable problem, but it's kind of a still problem. WASM's been out for a while, and I haven't seen these tools gain a ton of traction. And I almost wonder if it's a transpilation error or issue, because if you look at like TypeScript, maybe the largest, best supported transpilation thing still has some of these types of errors, even though it has amazing tooling around it. It kind of feels like that. Other cons was that it supports Java or Python and JavaScript. So, that's actually a con, but it is what it is. Some WASM pros, it lacks PHP and Fortran support. I said it lacks R support, but I actually think it supports R. All right. So then I was thinking, what other alternatives are there? So we have containers. Obviously, this is talking about containers. When you're talking about Kubernetes, you think containers. So the other alternative that I thought of was Firecracker, which I pulled this up because this, along with the streamlined kernel loading process, enables a less than 125 millisecond startup time and a less than 5 megabyte memory footprint, which is pretty fantastic, to be honest. So then I asked ChatGPT because I felt like this was a fairly good statistical analysis and analysis of the internet, effectively. I'm making fun of my own spelling. And this is what they were saying. Language agnostic. I don't really agree with that, but whatever. Performance. I also don't really agree with that because it's less performant than the native code, which you would be running in a container. So it's less than native code, which is an overhead. Security. It is more secure than running a naked full admin process, but I have actually yet to be proven that it is more secure than a container. I know people will talk about memory boundaries, but that's not actually implemented yet. And there are papers on how to fix that. And then the problem with how to fix those is it's going to slow down the performance. 100%. That's what the papers even say. Nobody knows exactly how much. That's what I'm saying, Apollo. How dare they support JavaScript? That's the key there. Portability, this is fine, except that, yeah, I mean, it's fine, but my container runs on any Linux as well, so I don't know. I know what they're talking about, like IoT and mobile devices, so maybe there's a thing to be said there, but portability doesn't really affect us people that are working on the back end. This might be more of an issue for mobile devices, IoT, and front end, devices. But backend developers, I've never had a portability desire or issue. Size and, I'm not running Raspberry Pis in my data center. Maybe you are. And if you are, cool, but I'm not. Also, my code compiles for Raspberry Pi, so I don't even care then. But size and load time, WASM modules are typically smaller in size compared to traditional JavaScript. This is true, but so is my Rust code. Native code is smaller in size than traditional JavaScript. Load times is also the interesting thing because these load times are in the same already running runtime. But if you're trying to talk about hard, untrusted multi-tenancy, you have to run, as far as I understand, you have to run a separate WASM runtime for a separate WASM VM to have that security. And in that case, I cannot believe. Now, the problem is I don't see anybody, and if somebody knows an example, I don't see anybody using WASM for untrusted hard multi-tenancy with code that I can access. I've never seen a runtime used in that way. So I am struggling with this in those scenarios. Don't care. Tooling an ecosystem is, I actually think that this is a negative. I think the tooling and ecosystem is kind of bad at this point. I'm also not sure you're future proofing. That's okay. Let's get into the article. Let's see what the article has to say at this point. Like I said, I didn't want this to be like a standard React. I wanted to take my notes and my thoughts, not research. Those were just my thoughts before I read anything. Maybe I'll learn something new. All right. Ferrymon co-founder and CEO. Okay. SpinCube. I should have looked this up. I didn't read anything about it, okay? Like I said, I'm coming to this new. Maybe this is the thing that does it how I've been wanting. Made with contributions from SUSE. Okay. Microsoft. I don't know about that. Where's the GitHub? It's supposed to be. Okay, here we go. SpinCube. Oh gosh. Container D shim spin. Ooh, that gets me excited. Okay, well, we'll come back to that. Let's read the article. In this interview, we dive into the details of WebAssembly, format, and Kubernetes, and Matt Butcher, co-founder and CEO of Ferrymon. Ferminion. Butcher is passionate about WebAssembly, distributed systems, and artificial intelligence. Butcher is, as is everyone these days. Butcher is one of the original creators or had a hand in the creation of Helm. Oh, not a good start. Not a good start. Cloud native application bundles. Okay. Open application model. Don't know what that is. Glide. Oh, this was an attempt to fix Go. And the Crustlet. He has okay. He has co-written many books, including Learning Helm and Go in Practice. In this interview, okay, let's go. Let's go. Can you please introduce yourself? Blah, blah, blah. I spent my career in software at the intersection of distributed computing, developing tooling, and supply chain security. It wasn't really one benefit that drew me to WASM, but how the characteristics of this technology mapped to the problems I was trying to solve, and more generally, the problems we've been trying to solve as an industry. portability, startup and execution speed, strong strong capability based sandboxing, and artifact size. So this kind of goes back to my things here. More secure startup times. These were along the lines of what I was thinking that they might be talking about. Again, I'm not sold on any of them, but and the portability also, when you're talking about distributed computing, even if you're writing for Windows or Linux, the like unless you need the same app to run on both, which would be weird, but that might be the case. But my Rust code can compile for both anyways, so I don't know about that. I've never heard of SpinCube, but we'll dig into it. All right. So yeah, I'm not sold on these. The portability, startup, and execution speed. Like I said, there's a lot of variables that go into that, and whether that would beat a container is, yeah, interesting. Strong capability-based sandboxing. Again, containers are adding this type of functionality in all the time, whether you need access to that GPU or not, and things like that. So for a while, containers had an issue with exposing those types of system level resources. But I think that's actually gotten a lot better as of late. Oh, this is exactly, I don't know why I smacked my own. I meant to tap it like that, but I didn't tap. This is exactly what I was thinking, but I wasn't thinking when I smacked myself. That is embarrassing. Azure Functions, like a way to run a function, but this is where you need that strong multi-tenancy. This is what I was thinking. At Microsoft, we're looking at Azure Function and other similar technologies where we see a lot of waste. Systems sitting idle, 80% or more just waiting for inbound requests. Virtual machines were sitting pre-warmed in a queue, consuming memory and CPU. This is a waste. I agree. They should do something to fix this. Is WASM the solution? I'm not sure. Waiting to have a serverless function installed and executed. So basically, they just had this feels more like extra pre-allocation. You just had stuff waiting around to have stuff executed on it that wasn't running stuff. This just seems like bad management on their part, not actually things. And all this wasted was done in the name of performance. We asked ourselves, what if we could find a much more efficient form of compute that could cold start much faster? Then we wouldn't have to pre-warm virtual machines. You still need the pre-warm virtual machine to run the WASM on, right? I don't know that I agree with that, unless if they're saying that this allows them to get rid of all the virtual machines. But WASM itself is a virtual machine. So again, and if the WASM virtual machine isn't pre-warmed, then again, I have so many questions that just aren't answered about this. So it was really all about finding a better runtime for the developer pattern that we call serverless functions. Okay. Okay. When we at Fairmont say that, we mean the software design pattern in which a developer does not write a server, but just an event handler. The code is executed with, right. I understand the idea of serverless is just an event handler. Yes, the first generation of serverless gave us a good design pattern, which was based for Lambda, Knative. The implementations were built atop runtimes that were not optimized for that style of workload. Virtual machines can take minutes to start, and containers tend to take a few dozen seconds. That means you either have to pre-warm workloads or take large cold start penalties. Maybe in the old days. Pre-warming is costly, involving paying for CPU and memory while something sits idle. Cold starts, though, have a direct user impact, slow response time. We were attracted to WebAssembly specifically because we were looking for a faster form of compute that would reduce cold start times. And at under 1 millisecond, WebAssembly's cold start time is literally faster than a blink of an eye. Okay. This cannot be starting the WebAssembly runtime. They're using a shared runtime here. And maybe they have a shared runtime that is secure. I haven't seen it. We'll see. Maybe that's their secret sauce here, is they made a runtime that is secure for running distinct untrusted workloads. Yeah. But what surprised us was by reducing cold start, utilize WebAssembly as a small binary size, and writing an effective serverless function executor, we've been able to boost density. That in turn cuts costs and improves sustainability, since this generation of serverless is doing more with fewer. Do more with less. That's the key. That's the key. Serverless functions are the main way people do edge programming. What? 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 Don't do serverless functions for edge computing. That's the edge is a lie. This is 100% edge is a lie. Because if your serverless is hitting a database, then all you're doing is moving your compute further away from the data that it's trying to do stuff with. This is the dumbest thing. If this is why people are using serverless functions, I think this is the dumbest thing. Unless if you are using those serverless functions to serve CDN stuff, which already is kind of serverless because you're serving a CDN. Unless if you're doing something like that with a distributed database or cache, it's the dumbest thing. Because of this runtime profile, WASM is a phenomenal fit for edge computing. We have seen content delivery networks, CDNs, yeah, like Fastly and more recent Cloudflare demonstrate that. And we're beginning to see more uses of WASM. But why do you need edge compute for your CDN? I don't get that. Somebody's got to enlighten me. I feel like I must be the dumbest person on the block, because I see these things and I just don't understand why people are doing them. But we're beginning to see more use cases of WASM on constrained and disconnected services, from 5G towers to automotive industries with cars running spin applications because of the efficiency and portability. One second, I think chat got disconnected. Let's see if refreshing that helps. Hopefully it's reconnected. I just lost all chat messages, but hopefully it's reconnected. All right. The other really nice thing about WebAssembly is that the OS and architecture neutral. It can run on Windows, Linux, and Mac. Sure. Look, I don't know why this is such a big thing. I never have been like, I want my function. So if you go and run a Lambda function, have you cared what OS it runs on? Especially because, look, what we're doing here is we're saying, handle this event. Handle event. What? And this might be an HTTP. It could be an HTTP. It could be anything. HTTP event. It could be whatever. Don't know, don't care. Handle event. Now, why would I care what this ran on? What I would care, unless if you're calling like Windows specific rendering APIs, I guess you could care what this ran on. Now, that being said, if you're calling Windows specific rendering APIs, are those exposed through the WASM virtual machine? I doubt it. Maybe they are. That's something to investigate. That's something to investigate. The other thing is, my code has always been able to compile for all of these, right? I don't know a language that doesn't compile for all of them. But I rarely run into a service or product that don't support all platforms. Kubernetes doesn't support Mac. Just saying. Likewise, it can execute on Intel. On Intel architecture or ARM. That means the developer, but so can all the code that you write today can do this. All your Rust, all your Go, all your C++. There are esoteric old libraries in C++ that don't support ARM because of the threading models and the fencing, specifically the fencing. But that's it. That's it. That means that developers can write and compile a code without having to know the destination is. Sure. I don't know that that's a huge benefit, but there it is. Yeah. Like I said, my code compiles for these just fine. WASM is indebted to earlier bytecode languages for sure, but it's more than that. WebAssembly was built with a stringent security sandboxing needs, deny by default, and capabilities based on system inferences or interfaces are essential to a technology that consumes or assumes it is running untrusted code. Now, this is where it doesn't actually provide good memory safety. Not yet. Like I said, there's actually research papers on how it could support memory safety, but it doesn't yet. And so, as far as I know, it's no safer at this point than a container. And with containers, you can even have something like not runc. What is it called? The kernel by Google, gvisor. You can run gvisor and actually get that memory safety. Yeah, it's a penalty, cost penalty, but you can do it. Second, WASM was built with the stated goal that many different languages, ideally any language, can be compiled to WASM. Again, though, this is on the language to support, not a WASM. So your language has to support compiling to WASM. JVM and .NET both started with a different perspective. The specific language be built to accommodate the runtime. In contrast, the very first language to get WASM support was C, Rust, Go, Python, and JavaScript all follow along afterwards. Rust has amazing support for WASM. WebAssembly demonstrated that it can target for existing programming language, while others decides that neither Java nor .NET have been able to do this broadly. Well, did I say decides? That didn't make any sense, and I went with it. WebAssembly demonstrated that it could be a target for existing programming languages, while after decades, and neither Java nor .NET have been able to do this broadly. Moreover, WebAssembly was designed for speed both in terms of cold start and runtime performance. While Java has always been notoriously slow startup times, WebAssembly binaries take less than a millisecond to cold start. Okay. Doesn't Java support WebAssembly? I feel like that's a misleading statement. Yeah. It does. I feel like that's a misleading statement. Oh, no. I think what they're saying here is that no other place, like nobody targeted Java, but that's actually not true. You have like Kotlin, you have Groovy, you actually have a whole bunch of Scala that all targeted the JVM, right? This is misleading either way that you read it. Yeah. So either they're saying that it's not supported in .NET and Java, which is misleading, or they're saying that nobody targeted the Java or .NET runtime like they have with WebAssembly, which is also not true because Java has a whole bunch of languages that target the JVM. I just listed a bunch. This article was written, I think soon. I mean, it was just, yeah, May 22nd. Moreover, WebAssembly was designed for speed in both terms of cold start. Like I said, unless if you have one that will, you can safely run multiple. I don't believe this. I actually just don't believe this. But the greatest thing about WebAssembly is that it's actually successful. That if it is actually accessible, it won't be long until both Java and .NET can compile to WebAssembly. This is actually just not true. They do right now. The .NET team has said that they'll fully support WebAssembly in late 2024. Hopefully Java won't be too far behind. Exploring the synergy between WASM and Kubernetes. SpinCube was released. Maybe there's like some edge support that's not supported. Like maybe that's what they're saying is like they're not fully supported, but not sure. Not sure because WASM on their website lists Java and Kotlin, which is a Java language. So I know like Kotlin is a huge language that does WebAssembly, which is a JVM language. So again, I don't know. Most of us are on Kubernetes for a long time. We built Helm, Brigade, OAM, OSM, and many other Kubernetes projects. When we switched to WebAssembly, we knew we'd start with developer tools and work our way towards orchestrators. So we started with Spin to get developers building useful things. We built Ferrymon Cloud so that developers could be able to deploy their apps to our infrastructure. Behind the scenes, Ferrymon Cloud runs HashiCorp's Nomad. It's been a spectacular orchestrator for our needs. As I said earlier, we've been able to host 3,000 users, supplied apps per worker node in our cluster, orders of magnitude higher than what we could have achieved with containers. But inevitably, we felt that the pull of Kubernetes gravity, so many organizations are operating mature Kubernetes cluster, it would be hard to convince them to switch to Nomad. So we worked together with Microsoft, SUSE, Liquid Replay, and others to build an excellent Kubernetes solution. Microsoft did some of the heaviest lifting when they wrote the Containerd support for Spin. Spin Cube's immediate popularity surprised even us. People are eager to try a serverless runtime that outperforms Knative and other early attempts at serverless. Should we try Spin Cube for the null cloud? Should we do this? I don't know. I wasn't prepared to do this. There are two parts of working with LLMs. There's training a model, which takes huge amounts of resources and time, and there's using the inferred against a model. This later part can benefit a lot from runtime optimization, so we have focused exclusively on serverless inferencing with LLMs. At its core, WebAssembly is a compute technology. We usually think of that in terms of CPU usage, but it's equally applicable to GPUs that AI uses for inferencing. Sure. So we'll be able to build SDKs inside the WebAssembly host that allows developers to do LLM inferencing without having to concern themselves with the underlying GPU architecture or resources. Most importantly, Ferrymon makes it possible to time slice GPU usage to a very fine level of granular. That's cool. This is actually really cool. But this also sounds like the marketing thing. While most AI inferencing engines lock the GPU for the duration of the server process, blah, blah, blah. This is what makes a WASM viable on the edge. I have no idea what this means about the edge. I hate the edge. Like I said, there's super good uses for it. CDNs are amazing, but the edge is mostly a lie. The edge is mostly a lie. Go watch that video. Where functions run for only a few IBlinks, those edge nodes will be only a modest number of GPUs to serve thousands of applications. Maybe. Inferencing takes a while. Most audacious design goal. WASM is only as successful it can run all major programming languages and run them in more or less a uniform way. Yeah. Is Kotlin not... How is Kotlin doing? I know Kotlin's big. Well, I think things are progressing well for all major languages other than Java. Until those languages have complete support, they have not reached their full potential. Wow. Let's unpack this statement right here. A language cannot reach its full potential without transpilation support. Is that a statement we want to state? That is what they're saying right here, is that a language is incapable of reaching its full potential without transpilation support. Yeah, I know Kotlin does, which is just a JVM language. I don't know. Obviously, there's probably some things that aren't fully supported or something in the WASI interface. That would be my guess. It feels very markety, Jabril. I agree. Transpilation is more of a quality of life thing, isn't it? Yeah. Wow. I want to talk to this guy about this statement. Because what he's saying is until you can transpile to another language, your language is garbage. Ooh, those are fighting words. I'd like him to write a little WASM. Just write a little by hand. I'd like to see it. How do you like that? Would you guys like to review more articles like that? If you find an interesting hot topic, I'd love to do it this way where I come up with my own take on it and then we compare and we see where I could learn some. I'm actually interested at this point to take SpinCube out for a ride and see what it has to offer. Maybe I'm wrong. I'm always up for being wrong. It's the one way I learn is be wrong, experiment, and move on and see where it lands. So let me know if you want to take SpinCube out for a test. Let me know how you like these segments, as this will be making it to my YouTube. If you watch this on YouTube, let me know how you're liking it in post. And join me live on Twitch and YouTube Live. So anyways, I gotta get going. Thank you, everybody, and have yourselves a fantastic weekend. And I'll see you guys tomorrow for some more fantastic content.